Welcome back, you guys, to the #1 data podcast on Spotify. So excited for you guys to be here. And thank you so much for your support over the past year for the podcast. Absolutely amazing to see how many of you guys are listening each and every week. We are not the #1 data podcast on Apple Podcasts yet. So if you're listening there, please leave us a rating and a review so that we can become one. My goal this year is to give you guys an action-packed episode every single week of 2024 and help a lot of you guys move to the next level of your data career. We've done something I think that's really cool that I've never actually had any other podcast do, and that is we want to give you a gift. If you leave us a rating and a review, or if you already have, thank you so much. We want to give you guys a gift. And so down in the show notes down below, you'll see a link. And basically you can get a copy of our Data Career Podcast Navigation Guide sent to you if you just take a screenshot of your rating or your review. And what that is basically a PDF that organizes our top episodes by topic. So that way, if you're new to the podcast and maybe you've listened to the early episodes, or you're struggling with something specifically, instead of having to scroll through, we picked the best episodes for you by category. And we want to give that to you as a gift for saying thank you so much for supporting the podcast. So you can do that in the show notes down below by clicking the link and uploading your rating or review. Happy New Year, everyone. Welcome to 2024. As you might be able to hear, I'm a little under the weather. My voice is kind of fried from this cold that I've had the last 10 days. I'm finally getting over it, I think. But I hope this year is absolutely amazing for you. I hope 2024 brings you a lot of happiness and joy, and I hope you're able to take the next step in your career. And I hope this podcast is a valuable resource to you as you're doing so. Like I said, we're going to have an action-packed episode every single week that's going to help you take your next step in your career. If you're looking for more help in landing your first data job, we of course have the Data Analytics Accelerator. If you haven't even looked at the page or you don't even know what it is, basically I run my own bootcamp where I help you go from zero to data analyst in about 100 days. You can find the links for that in the show notes down below. And I highly encourage, if you haven't watched my webinar, to watch the webinar, How to Land Your First Data Job, even if you don't have experience. If you haven't checked that out, it's basically I'm going to give you a roadmap to do so, and I'll also give you a discount to the program as well. Now, this episode is a little bit different. It is a recording of a presentation I gave live at the Big Mountain Data and Developers Conference in Salt Lake City, Utah in November. And I'm talking about linear programming, which is something that not a lot of people talk about, and I don't think a lot of people know what it is. And it is not the most sexy subject of all time, but it's actually what I did when I worked for ExxonMobil. This episode gives you an idea of what the concept is, gives you some examples. We kind of go through the math a little bit behind linear programming, talk about why it's useful and where it's used. So it is a little bit more of a technical episode than I typically do. But I think it's really interesting because I think it gives you an insight to what I actually did in the data world. When I worked for Exxon, my official title was optimization engineer, but I worked basically for the research part of ExxonMobil. And in this role, I was helping Exxon decide what crude oils to buy from around the world based on current prices and world situations. We basically would create mathematical models of the refineries. So basically we took all of the refinery process and turned it into a big math equation using machine learning, which was really cool. So I got to help make these machine learning models. So once again, we were doing machine learning. So that is kind of more of a data scientist position. And then once we had these machine learning models, we would basically run, you can think of it as simulations, but the more proper term is we'd optimize the model to make certain outcomes happen. And this is actually the fourth type of analytics, which is prescriptive analytics. So how do you make favorable outcomes occur? And this is part of what's called operations research. It's kind of a weird niche field in data analytics and data science. It's kind of like part of both, but kind of sits in between them. It's really like an interesting field, and it's very common in supply chain and logistics. So for instance, I was dealing with buying items and shipping them, right? So that's very supply chain heavy. The items being barrels of crude oil. You don't really think of that as something that you buy necessarily or an item, but it is. And so this is really what I worked on for about 2 years at Exxon, was how do we make these models? How do we improve linear programming? And how do we make better decisions about what crude oils we should buy so that we can reach all of our regulations, safety, and emissions, as well as make the most money for the company? So I think that's pretty interesting to like kind of hear what I was working on when I worked at ExxonMobil. I hope you guys enjoy this episode, and I'll be back next week with a new episode. So see you guys soon. Oh, and I did video the whole presentation. So if you'd like to watch video, you can actually just watch the video on Spotify. This is kind of something that's really cool about Spotify is they actually allow video podcasts. So you can actually watch the video inside the Spotify app. All the episodes that we put out on this podcast actually have a video element, so you can always watch it on Spotify, or if you'd rather, you can watch it on YouTube. All right, now to the episode.
Welcome to the Data Career Podcast, the podcast that helps aspiring data professionals land their next data job. Here's your host, Avery Smith.
I can't believe this many of you guys showed up for linear programming. You guys must think you're in the wrong room because this is not a very sexy topic. That's okay, we're gonna talk about it anyways. So thanks for coming. This is using linear programming to solve business problems like finding McDonald's healthiest meal. Who here loves McDonald's? All right, a few of you guys. The rest of you guys are liars. Just kidding. I don't really like McDonald's that much, but they have their menu online, which makes it really easy to do data analytics on it. So I'm excited to be here. My name is Avery Smith. I have my LinkedIn on a couple QR codes. If you guys want to connect with me, go ahead. Just make sure you add a little note so that way I know that you guys were here. Of course, thank you to our sponsors for the event. I actually came to this event, I think in 2018. At the time, I was still in college, and I listened to a lot of presentations that were really cool. I remember one, I don't remember the person's name or anything. I think he was bald. But he talked about allergies, like predicting allergies in Utah. And I was like, whoa, he was using machine learning to do that. I was like, that is so cool. You won't remember me probably, but you remember my presentation. And I'm not bald, I'm just getting there. So that way, in a couple of years, you can remember what I kind of look. This is about me. I'm Avery. Right now, I run a data analytics bootcamp where I help people transition their careers from like being a teacher or from being an Uber driver or from being like a music therapist into becoming a data analyst. So that's what I spend most of my time doing. I've taught at MIT. I've run my own data analytics consulting company. I was a data analyst for the Utah Jazz, worked for ExxonMobil and a biotech company called Vapor Sense. I also run one of the biggest data podcasts online called Data Career Podcast. That's really more geared towards junior people getting into the field of data analytics, but sometimes we talk about interesting topics. This presentation will be on there. If you couldn't tell, I'm recording as well. So hopefully that works. Here's a little bit of my timeline, just in case you're curious. Basically, I studied chemical engineering at the University of Utah. And within honestly 3 weeks, I was like, crap, I hate this. But I couldn't figure out what I wanted to do instead. And I got really lucky and I worked for this company called Vapor Sense that is a biotech startup. I was there actually as a lab technician. So I was like wearing a white coat, goggles, the gloves and everything. And the cool thing is this company was all about creating these sensors that would basically sniff things in the air and tell you what's present. And so it had really cool applications for like sniffing bombs at airports or sniffing for drugs like on bus stations and stuff like that. And it was actually very data driven. So we had a data scientist on staff and I was actually just like running the experiments. So it was actually pretty interesting because I got to like play, I hate saying this phrase, but I got to play with meth. Like meth the drug, like quite often. Never like inside of me, just always on the outside. But that was kind of my job as a lab technician. And then one day the data scientist quit and we were a small company, we couldn't really find someone. And I was like, well, how hard can this be? I hate chemical engineering, so maybe I can get into this data stuff. And so I became a junior data analyst. Oops, I forgot to change this slide. And then I became basically a data scientist for them. And then I interned with ExxonMobil. We'll talk about that a lot today. Most of my presentation is actually what I worked on when I was at ExxonMobil. So really relevant. Then I worked at ExxonMobil for about a year and a half. And then I quit in 2021 to do entrepreneurial stuff. So I started a consulting firm. I taught at MIT that year. I did consulting the next year and half courses, teaching people online, half consulting. And then this last year, I've really been just working on my boot camp, which is I help people become data analysts. This is what we're gonna be working on right here, is how an algorithm basically ordered this, the McHealthy combo is what I'm gonna call it. And I'll break it down in this presentation. I have a 5-minute video on my YouTube if you guys want to check it out. I kind of explain this, but you guys are going to get the not 5-minute edition, which will be a little bit longer. So I'll be able to explain a little bit more about what linear programming is and how it's important. So just curious, does anyone know, by show of hands, who knows what linear programming is? Okay, maybe a third. Who here uses linear programming? Okay, a little bit less. I didn't really know what linear programming was until I had that internship at ExxonMobil, which is where I really used linear programming on a day-to-day basis. And hopefully, if I do my job right, by the end of this presentation, all of you guys will know what linear programming is, hopefully. So linear programming is basically the unsung, ugly, and forgotten stepsister of data science. It's like part of the data science family, but no one really talks about it. It's not sexy, it's not AI, it's not a neural net. It's just kind of there, but it's very useful, okay? So because it's not that sexy, I asked generative AI to draw the presentation today. This is what it came up with. This is linear programming with finding McDonald's healthiest meal right here. This is linear programming, not sexy. Neural net, sexy. Linear programming, not so sexy. It's pretty useful and it's fairly simple, which is a good reason why people like it. It's also called linear optimization because most of the time you're going to be optimizing for something, either a maximum or a minimum. But basically, linear programming or linear optimization, you're trying to make something good happen or you're trying to prevent something bad. You're minimizing the bad things from happening. That's what you're trying to do. And really in analytics, there's 4 types of analytics. There's 2Ds and 2Ps. There is the descriptive, which talks about what happened. There's the diagnostic, about why did that thing happen. There's the predictive, what will happen in the future. And then the last one is the one that people don't talk about a lot, and that is prescriptive. And it's how do we make it happen, okay? And so really a lot of the times, like a data analyst is going to be focused more on the descriptive and the diagnostic. A data scientist is going to be really focused in this predictive space. But like not a lot of people are working on this prescriptive problem. And that's actually linear programming or linear optimization is where prescriptive jumps in. Now I'll ask you guys, we'll poll the audience here. If you were a CEO and you're like just learning about analytics, which one of these is the most interesting to you? Yeah, the last, why? Exactly. So it's super funny that we live in this world where it's like, oh yeah, like I'm gonna put this up into Tableau and talk about what happened. Or I'm gonna make, a random forest model to predict what will happen. But really at the end of the day, if you can actually get the prescriptive to work well, how do we make it happen? In my opinion, I think that's the one that CEOs will like the most because it's like, how do I make $1 bajillion? Tell me AI, that's what we really wanna do with linear programming. And we'll make $1 bajillion today as we go through an exercise. So linear programming can solve all sorts of different problems. One of the ones we're gonna be focusing on today is the healthiest McHealthy combo meal at McDonald's. So originally this started out as a project and I wrote a blog and I made a YouTube video about it. And like in the YouTube video, it's like, I wanted to set up the problem and it was like, I love McDonald's, but it makes me fat. And like only half of that is true. I don't really love McDonald's, but it does make you fat. So just pretend that we all love McDonald's here. It can solve your Sudoku puzzle for you, actually. If you're making high quality but cheap cat food, it can help you with the blending properties of how much stuff to add into your formula in order to reach certain nutritional values. Deciding what products get the prime real estate space at a grocery store. What crude oils should a refinery purchase? This is the problem I was solving at Exxon when I was there. Deciding how many Model Ys and Model 3s Elon should make. How should farmers plant their crops? That's something that we'll talk about today a lot. Shortest path of delivery for logistics. So like, when you see your Amazon package is 7 stops away and like you can kind of see where those stops are, like this is all solved with linear programming. And I'm a big sports guy. So anyone ever curious how they make like the MLB or the NFL or the NBA schedules? It's actually with linear programming. So some pretty cool problems that we can solve with linear programming. But a lot of the times it's really only going to be for people in supply chain logistics, transportation, agriculture. This is scheduling and production planning is honestly part of supply chain and logistics too. So, and this is often like all really called operations research. Has anyone heard that term before, operations research? Yeah, not very many people because I don't know why, but it's like a whole field of like that it's either sitting in data science or just adjacent to data science with honestly, it really covers a lot of optimization and simulation. Those are 2 things in data science that we just don't talk about, but they're actually really useful. And so the organization that I sat in when I was at Exxon's obviously a huge company. I was basically in the research arm of ExxonMobil inside of this group that was basically the operations research group. So we did optimization and simulations of downstream, which basically just means refineries and chemical manufacturing plants. And my team actually was called the production planning team. And so basically what this means is you're planning your production, which is like how much stuff you're gonna make and what stuff you're gonna make. So this is really what I did at ExxonMobil. Yep. So this is me at ExxonMobil. I was on a part of this production planning team. This is called the cube. It's like supposed to look like it's floating in the air. And this is the ExxonMobil campus in Houston, Texas, where I worked for like 2.5 years. Okay, in linear optimization, we're always maximizing or minimizing something. Like I said, a lot of times we're maximizing product or minimizing something bad that we don't want to happen. So whenever we're doing a linear optimization, this is always what we want to start with is what are we maximizing and what are we minimizing? So for example, to go through some of those examples, in this example that we're going to do with McDonald's, I'm minimizing my calories. I have to obviously get like enough nutrition in my body, right? But I don't want to like eat like 10,000 calories like I would normally do if I went to McDonald's. Honestly, I was going to go to McDonald's before this presentation and like pick up some stuff, but I just didn't do it. So I could have shared, like pass it around. You might want to minimize the cost to produce cat food. You might want to maximize revenue of your store, maximize profit of your refinery. That's what our objective function at ExxonMobil was. The objective function is basically what you're trying, it's the mathematical formula that basically shows what you're trying to optimize for, either at the top or the bottom. You might want to maximize profit of the farm. You might want to minimize miles driven for a delivery driver, right? Or maximize revenue for your sports league. So after seeing all of these, especially, over here on the left-hand side, now do you guys understand why CEOs love linear programming? This is where the money can be made. You're basically just trying to maximize profit. So you're always going to be maximizing or minimizing. Okay, so say it with me. What are we trying to do? Maximize or minimize. But there are constraints, and those constraints are preventing us from making lots and oodles of money. So for example, we have apple farmer Steve right here, right? Steve has an apple farm and wants to make the most amount of money possible, okay? He's hoping to become the most rich person on planet Earth, at like, I don't know, what is that at now? $200 billion or something? That's what Steve's trying to do. So he wants to maximize the apple farm profit. So if you were Steve, what would you tell Steve to do? You'd probably tell Steve to have, I don't even know what this number is, amount of trees, right? Because the more trees you have, the more apples you can sell. The more apples you can sell, the more money you make. You'd probably tell him, well, you don't really need any fertilizer. That's just a cost, right? We don't really need fertilizer. And you could sell each apple for $1 million. This is how Steve becomes a trillionaire. This is the formula for it, right? But unfortunately, that's not realistic. That's like not what happens in real life. There are constraints. Those constraints are going to be, things that are in reality that are just unfortunate, I guess. So how do we solve these? I'm not going to be focused as much on like how to actually solve linear programs. I think part of the reasons why operations research really isn't talked about that much is the majority of people who work in operations research either have a master's degree or a PhD a lot of the time. Now, that wasn't the case for me. When I started working for Exxon in operations research, it was the summer after my junior year in college, and I ended up getting a full-time job. So I only had a bachelor's degree. I did go on to get a master's in data science, but that was while I was at Exxon. But even then, like the math behind solving linear programming is not super easy and not super fun. There's a lot of people who are honestly smarter than me that can probably explain it better than me. But if you're really curious and you really want to nerd about math, you can look up the simplex algorithm or interior point algorithm. I'm not going to talk about them today because honestly, I'm one of these people, and you guys might be the same, you might be different. There's basically in tech, there's two types of people. The people who care about the technical stuff and the people who get stuff done. Now that's mostly a joke, okay? That's mostly a joke. I'm one of the people who just try to get things done. And it's I know it works. I don't necessarily know why it works type of a person, right? And that's good and it's bad in a lot of ways. But I'm not going to be talking about how to actually solve these. I'm going to be talking more about how we can apply them to businesses. And the cool thing is, the people who had used linear programming before, will you guys raise your hands? Did anyone use it at work? Is it like a custom, do you guys have custom software that does it for you? Yeah. That's the majority of cases now, is it's actually very rare to be solving linear programming on your own. And even if you are solving it, and I mean on your own without a software, and even if you are solving it on your own, there's been probably about 5 to 10, they're called solvers, that are open sourcely available that you're going to be using anyways. So the examples I'll show you today, where I'm solving on my own, I'm still using someone else's solver. So you're never going to be writing your own solver from scratch. So I don't think it's super important to talk about, and I'd rather talk about the applications. But there's well-written libraries and softwares that will solve these problems quickly and efficiently. It's very rare that you'd ever have to rewrite these on your own. Okay, I'm gonna introduce you guys to a linear programming problem. We're gonna start very simple with 2 variables and 3 constraints to help out our homie, Farmer Steve. I got Farmer Steve's bird's eye view of his farm right here. Here's Steve's farm, right? The reality is Steve has 100 meters by 100 meter farm for a 10,000 square meter farm. Steve, he's been doing good, but he only has enough money to buy 500 pounds of pesticide and 700 pounds of fertilizer. And he makes 2 types of apples, Pink Ladies and Yellow Delicious. Pink Lady trees produce $195 per tree. Yellow Delicious or Golden Delicious, I obviously don't go to that aisle to know what the real name is, produce $159 per tree. Each tree needs 1 meter squared of space to grow. Pink Ladies require 4 pounds of fertilizer and 3 pounds of pesticide per tree. The Yellow Delicious require 2 pounds of fertilizer and 1 pound of pesticide. And obviously, this is really obvious to me and you, but we can't have negative apples, right? That's like super obvious to us, but guess what? To math, it's not obvious, and it will try to make negative apples. So yeah, and negative trees as well. So yeah, exactly. In fact, actually, you're actually right. It can't have negative trees because in this example, instead of doing it by apple, we're doing it by tree just because it was a little bit easier. Okay, so how many of each tree should Steve plant if he wants to maximize profit? All right, so let's do some guesses. So if Steve was trying to maximize profit, we're going to have a Pink Lady, number of Pink Ladies and a number of Yellow Delicious, and we'll have some guesses. Maybe we'll take 3 or 4 guesses on what you guys think. And then maybe we'll go ahead and do some predictions as well. How about that? On the money that Steve makes. Just as a reminder, he has, I think, 10,000 meters squared of space. These are the requirements here. He has, 700 pounds of fertilizer? 700 pounds of fertilizer. So 700 of F. I'm just gonna write that down there. And 500 of P. Sorry, I have really good handwriting. P, so this is F and that's P, okay? Any guess on money and also the limiting factor? Like, do you think we're gonna run out of space, fertilizer, or pesticide first? Okay, fertilizer first, and then money guess? 3 times 100. Yeah, like 60,000, I think, or something like that. 65,000, all right? We got Mac M over here with a good guess here. Any other guesses that you guys have? All right, what's your name? We'll just put this, if someone wants to do the math, they can, but we'll put it at, this is like basically almost the same as this, but this is gonna be more expensive. So we'll put it like 70K or something, because I'm too lazy. Okay, we got some guesses. I'm pretty sure you're like almost exactly spot on, which I'm very impressed if you are. We'll get to it here in a second. So here's the thing, is we could actually, this right here, Steve's farm, I've actually tricked you guys. And we're going back to 9th grade. And this is actually one of those story problems that you hated in 9th grade that your math teacher gave you, where it's like Steve has all this, yeah, this is one of those. And we can actually create mathematical equations to explain what's going on here. So the first one is the revenue that Farmer Steve makes is just the number of Pink Lady trees that he has times 195 plus the number of Yellow Delicious trees he has times 159, right? Then we know that the number of trees, Pink Lady trees plus the number of Yellow Delicious trees has to be less than 10,000. In this case, I made it really simple because 1 square meter is just the size of these. So we made that one really easy. This one right here is saying that 500 is the absolute max we can spend. And honestly, these should be greater than or equal signs. So 500 for the pesticide has to be less than, because for every Pink Lady tree that we need 3, and for every Yellow Delicious, we have 1. And then same with the fertilizer. The max we can have is 700, which requires 4 for the Pink Ladies and 2 for the Yellow Delicious. And so with this, we now have 4 equations that basically explain Steve's farm. And yeah, it's just one of those story problems from 9th grade. My question for you guys is, how much money will Steve make? Is there gonna be more Pink Ladies or Yellow Delicious? Okay, so here's what I did, is I actually just put this simple thing in this website, and I honestly don't remember the website's name. I just Googled it and it was the first thing. But I basically just created the same equations I just showed you on the other page, and I hit solve. And what it was able to tell us was the max amount of money was indeed $55,000. And so I don't know how in the world you got that, Mac, but that is correct. $55,000 is the amount that he can make. With that, I think you can dive into some of the results. So they make these graphs a lot of the time. Basically, this is called the feasible space. Since this problem only has 2 decision variables, only things we're deciding is how many Pink Lady trees and how many Yellow Delicious trees, right? And so we can actually plot this here, and the feasible space, these 2 lines are given up by the constraints that we showed you. These two lines right here, notice that they're lines. You guys remember the formula for lines, right? We're just like looking at like basically y equals mx plus b. I tricked you guys because if we go back here to these equations, for instance, this 500 one, right? And then what we do is this b actually becomes like b divided by the whatever equation that, or whatever the slope of y is. So basically that's like, this is the slope of p and this is basically the slope of y basically. And also has the factor of like the minus $500. But this is basically this right here and this right here. These are just all lines that I just showed you. And so when we graph it, you can actually realize that, okay, the number of p versus the number of y can only exist in this shape. And then what you can see down here is the variables. It'll show you what it actually optimized to. And so indeed, Mac was correct that there are no pink ladies. There are 350 yellow delicious. And we can see that this is at lower bounds because we can't have less than 0 apples. I told you it would try to have negative apples, right? It tried, but it got to the border. And then actually what we have right here is they call it a reduced objective coefficient. At Exxon, in our software, we call it a shadow value. I know, kind of sounds like cool and dark, right? A shadow value. And what this value is actually telling us is this is how much money we would save if we could actually have -1 pink lady apple tree. So this is telling us how much we don't want pink lady apple trees, basically. And if it would have solved, for instance, if we would have had enough, I'll show you this here in a second. We were limited by one of the 3 constraints. If we would have gone all the way up to our limit, I guess we could have infinite yellow delicious, so never mind. And then yes, looking at the constraints, you will see that the upper bound we hit was indeed on the fertilizer. We're no longer going to Farmer Steve, we're going to McDonald's Avery, okay? And so I'm trying to lose weight and I only want to eat at McDonald's. So I want to minimize calories. That's like my objective, right? But I still need to reach all my nutritional values. So what are the best combinations of foods for me to eat? And how many calories is that a day? Okay? I'll show you guys on the next slide right here. Here's the McDonald's menu if you're unfamiliar. The golden arches provide many a thing for us to eat. I think it's over 200 items on the menu. So here's what I'm going to try to stay between. This is from like some health website. I don't really know if I believe in these. This protein seems super low. This is what they suggest. And the idea is basically whatever you eat, you're going to have that item's carbs. So if I eat a Big Mac and I eat chicken nuggets, well, then I'm going to have the calories from the Big Mac and the chicken nuggets, so on and so forth. So this is kind of the equations we're setting up, the sum of the items sugar, the sum of the items protein, stuff like that. We're trying to minimize calories, but I'm trying to, I can eat between 80 and 100 grams of sugar. I have to at least get 260 grams of carbs, and I can eat between 40 and 60 grams of protein. Here's the McDonald's nutritional facts for popular menu items right here. So basically for each one of the items, sorry, it's a little blurry, the hamburger, the cheeseburger, the double cheeseburger, the McDouble, the quarter pounder, the calories from fat, the total fat, the saturated fat, the trans fat, sodium, so on and so forth. McDonald's has to give this, I think, now because they've been sued a bajillion times, or everyone has to give their nutritional values. I don't really know, but they're available. And what someone did really nice was put this whole data set on Kaggle. Raise your hand if you've used Kaggle before. If you haven't used Kaggle before, it is the best place on the internet to find all sorts of obscure data sets. So the nutritional facts for McDonald's, or you can look at some of these other ones I've looked at recently, data analyst job postings, billionaires. There's like literally anything you want to find, there's a data set on Kaggle. So great place to find data sets. And this is what that data set looks like. It's just a CSV where it has the categories in one column and then the items. And then of course has the calories, the total fat, all that good stuff inside of a big CSV. 260 menu items. So instead of just, P or Y, there's now, 260 options of different types of apples, so to say, decision variables, and 13 possible constraints. So it's like things like the sodium, the carbs, all that good stuff, basically. I solved this problem actually with Python. Instead of just doing it in some online forum, we did it via Pulp, P-U-L-P. This is one of the libraries in Python that allow you to set these up fairly simply. And this is kind of what that part of the code looks like. I can show you guys the code at the end if we want to go over it. I just thought it's kind of boring, to be honest. But basically what you're doing is you're creating a problem where you're adding the constraints one by one. So this is me adding this is at first saying that I want to minimize the calories. The first thing you say is like the thing you're maximizing or minimizing. Then I have the total fat constraint, the saturated fat constraint, the carb lower constraint, the sugar is lower, the sugar's upper, the protein lower, the protein upper, the sodium. So those are the 1, 2, 3, 4, 5, 6, 7, 8. 8 constraints I guess I used, not 13. I'm solving this up. I'm telling Python to solve it. Okay, any guesses on what the McHealthiest combo meal looks like? Orange juice, okay, all right. I heard a good one back there. What was that? Apple slices, nuggets, some salad, milk. Okay, let's talk about water. It is on the menu, but its nutritional value, other than I guess you need to drink water, is 0. So for our mathematical sense, we do not need to drink water. We might need to set up some other constraint where it's like, we have to take so many grams of the beverages or a liquid, because we don't have that right now set up in the constraints. So math is dumb. If you don't tell math exactly what to do and what the exact reality is, it's not gonna do it. It does not care that you're tired of what it tastes like. It will say, this is the healthiest thing to eat, so eat it. We are trying to minimize calories, right? So eating a lot is typically bad for calories, minimizing calories. But that being said, we do need, like, for instance, we'll talk about this, but the minimum carbs of 260, which I don't even know what that even really means, that's actually really important, because if we set that minimum carbs to 0, it'll basically say, hey, don't eat anything. Oatmeal, I love that guess. Coffee. So when I originally did this project, and I made the YouTube video, you guys should all go watch the YouTube video, because I actually, after I figured it out, I went to McDonald's and filmed myself in the drive-thru, and I explained to the drive-thru person, hey, I'm a data scientist, I just solved this problem of finding the healthiest meal, I'm gonna order it. And the first thing I asked, they're like, no, we don't have that anymore. And I was like, oh, okay, great. Here's the answer. We're gonna have 6 side salads, 5 non-fat latte with sugar-free French vanilla syrups, small, 2 oatmeals, great guess, 2 hotcakes, and 1 apple slice. Yeah, give it up for this McHealthy combo right here, right? We did get a lot of drink. I'm not a coffee drinker, but that's probably a lot of like caffeine, right? Who here has used Streamlit? Anyone? Only like maybe a third? Okay, everyone write down Streamlit, especially if you've ever used Python before. Streamlit is making it so easy to create the coolest little web apps in Python in like 30 seconds. If you use ChatGPT, it can do it really quickly. If you do it by hand, it takes a little bit longer, but it's still way faster. So what I did is I created the McHealthy Streamlit app. So basically what I did is this is all built in Python, the front end and the back end. And what it allows me to do is give you guys, the users, an option for what we want to do with our diet. So I'll open it up to you guys. We have all these things on the left-hand side that are part of our constraints. Like for instance, we could up our sugar instead of having a max of 100. Let's do it like I do it, and like let's do it like 1,000. Or we could do the protein, or we could take the carb min up quite a bit. Basically, when I was running through this last night, I think the only thing, and this is something that we can actually go in and find in our results, is like where are we constrained? Actually, you have that right here, I think. Yeah, so carbs, the min at 261 is where we're constrained, and sugar at 100. Protein we're pretty close to at the bottom. Now, some of you are saying, oh, great, Avery, that's awesome. But in the examples you gave today, like for instance, the slopes were known. So like I told you that it takes 7, pounds of pesticide for the pink ladies or something, right? I told you that. Or we use the McDonald's menu and we know that there's 5 grams of fat in every, McDonald's, what's the Big Mac, right? Or whatever, right? Those were all known. And some of you guys might be wanting to take this back to your businesses and you're like, well, what the heck? I don't know what my slopes are. Avery taught me all this stuff. I don't know all these slopes. And here's the cool thing is you don't have to know these slopes. You can actually, if you have empirical data, which I think I have on the next page, like this, basically, you can calculate your slopes using linear regression. Now that does kind of require your data to be a little bit linear. There's things you can do to try to make it more linear, like logs and transformations and stuff like that. But this is what I did at Exxon. This is my full-time job. I'd basically take plant data, so refinery data for like one individual reactor, right? And we don't know any of the coefficients, like we don't know the formulas for how these things work, but we basically look at like, okay, well, how much of like gasoline did we get out on the other side? And what was the temperature at? What was the pressure at? What did we put in? Like, what were the qualities of the stuff we put in? And we basically did linear regression, multivariate linear regression, looks like this. This is, machine learning, simplest form basically. And we would basically find the slopes for it. We'd create these equations, and then we'd put those equations into linear optimization or linear solvers, and then we'd optimize the whole refinery. So we'd create these equations from scratch empirically with data that kind of looked like this, and then we'd go back and run linear optimization off of that. So you don't even have to know your slope, right? This is what I would try to do, is I would try to maximize refinery profit when I worked at ExxonMobil with keeping in the constraints of we can't buy unlimited crude oil. We don't have enough money. Even Exxon doesn't have enough money to buy unlimited crude oil. Even if we could buy unlimited crude oil, these could only take so many barrels of oil per hour type of a thing, right? There's only about 20 to 60 different crude oils you can buy from all over the world. We can make between 8 to 40 different products, like, gasoline, we can make diesel, we can make asphalt, we make that in refineries, we can make plastic in refineries, stuff like that. So like when I would build these models, I was building, maybe a tenth of this at a time, and we'd have other people building a tenth of it at a time. And then we combine all of it together. So we'd have the biggest Excel workbooks you've ever seen that were existing for 20 years straight. Anyways, that was kind of fun. They're getting more modern as they go. They're getting more modern. But anyways, that's what I did for a living right here, was solving this. And I hope this was useful for you. So thank you guys so much for being here.